everyone, my name is Parmida Heydari and today we are going to learn Kubernetes services. A service is a method for exposing a network application that is running as a one or more pods in your cluster. We use a service to make set of pods available on the network so that clients can interact with it. Each pod gets its own IP address. The service API part of Kubernetes is an abstraction to help you expose groups of pods over a network. The set of pods targeted by a service is usually determined by a selector that you define. Take a look at this example. Applying these manifests, create a new service named MyService with the default cluster IP service type. Let's look at service types in Kubernetes. Cluster IP. Choosing this value makes the service only reachable within a cluster. Node port exposes the service on each node's IP at a static port to make the service reachable from outside of the Kubernetes. Load balancer exposes the service externally using an external load balancer. External name maps the service to the content of external name field. Also, there is one more service type, headless service. For headless services, a cluster IP is not allocated. kubeproxy does not handle these services, and there is no load balancing or proxying done by the platform for them. Headless services report the endpoint of IP addresses of the individual pods via internal DNS records. What is internal DNS? There is a core DNS pod in kube system namespace, and it is responsible for assigning DNS name to each service and pod, following a specific naming which is contained such as service name, namespace name, svc.cluster.local for services, and pod name namespace name pod.cluster.local for pods. Kubernetes DNS enable interaction between services and pods. Now it's time to apply our first service YML file. Here I have a service YML file, and service type here is node port, and I have a pod Nginx which will expose on 80, but target node port here is 380. And let's apply this manifest. By applying these manifests, I create a pod and a service by running kubectl get pods. Here I have Nginx pod, and I have a service, Nginx service. Type here is node port, and let's look at this service outside of Kubernetes cluster. But first, take a look at node IP. Here our IP is this one, and with the port of 380, it is reachable. What is Ingress? Ingress exposes HTTP and HTTPS routes from outside the cluster to services within a cluster. You can configure Ingress to give services externally reachable URLs, load balance traffics, or terminate SSL TLS. You must deploy an Ingress controller such as Ingress Nginx. Here you can find how to install Ingress Nginx and by the provided YAML file and Helm chart, which we will learn later. After providing and installing Ingress controller, you can define an Ingress YML file. Look at this example. Whenever client requests to foo.var.com/foo, it will conduct to service 1 on 80 port, and whenever client requests to foo.var.com/foo, it will conduct to service 2 on 80 port. Notice you have to have Ingress controller at first. Now let's see some Ingress Ingress controllers in Kubernetes. We can define several Ingress classes in Kubernetes like Nginx, which supports features like SSL termination, path-based routing, and load balancing, Traffic, an open source Ingress controller that provides dynamic routing capabilities, integrate easily with various backends, and supports features like automate SSL certificates, Edge proxy based on Edge proxy, and it offers robust load balancing and high availability suitable for application requiring complex routing rules. Istio Ingress, part of Istio Service Mesh, providing advanced traffic management features, supports service-to-service communication and security policies. Kong Ingress controller, built on Kong API gateway, it provides API management feature, supports plugins for extended capabilities like authentication and rate limiting. AWS load balancer controller manage AWS application for Kubernetes services, allows integration with AWS features like path-based routing and SSL termination. Glue, an open source Ingress controller that acts as an API gateway, supports multiple protocols and integrate with various service meshes. Contour, an Ingress controller based on Envoy proxy, provide advanced load balancing feature and supports HTTP2 and gRPC. Cilium Ingress controller leverages eBPF technology for high-performance networking, offers enhanced security and visibility for microservices. Don't forget to subscribe my YouTube channel.